So welcome everyone to this presentation between KONE and Solita. Today we will talk about tech meets human insights, smarter capacity planning at KONE. I am Alessandro Mancuso, Capacity Planning Manager at KONE. I have a responsibility on a global scale to support the operations managers in the capacity management of their technicians and workforce planning of their work through data-driven decision-making. I have a strong academic background in analytics and operations research at the Politecnico di Milano and Aalto University.
And I am Roberto Fierimonte, machine learning architect here at Solita for the past couple of years. I have around 10 years of experience in designing, implementing, and productionizing AI solutions across multiple industries, countries, and technology. Most recently, my focus has been working in the Databricks space. However, working in technology consulting allows me to learn something new every day, which is what I like about this job.
To give some context about KONE and this project, KONE is operating in three different business lines. The first one is about the production and installation and delivery of elevators and escalators around the world. The second is the service business, where I personally operate, which is in practice the maintenance of the elevators and escalators throughout the life cycle. And finally, the modernization business, where the units at the end of their life cycle are then modernized completely or partially. We are proud to say that we move around 2 billion people around the globe on the elevators and escalators that we maintain. The company has been founded in 1910. On average, we deliver every day roughly 750 units, and we do maintain over 1.7 million elevators and escalators around the globe in close to 100 operating countries. KONE employs roughly 60,000 employees, and of which half of that, 30,000, are our KONE technicians. And the capacity management that we take care today is about the capacity of these 30,000 technicians around the globe. We serve roughly 600,000 customers worldwide.
KONE is also a very important and large account in Solita. We have an extensive collaboration that started in 2015, so around 10 years ago. And we've worked with multiple parts of the organization, such as design and strategy, R&D, and IT. Our projects span from business and service design, customer insights, data and analytics, and technology consulting. Since 2020, we had around 60 projects in the account, which involved 80 Solita consultants. And the account is still very active at the moment with 14 active projects and 26 consultants. We have also published a public reference for our joint work on our predictive maintenance solution for KONE 24/7 connected services. You can read more on the Solita website.
Giving some context on this specific project in the KONE service, so the maintenance of elevators and escalators, our technicians are taking care of specific geographical areas, and they take care of all the units in this area. So you can see in the right side of this slide a representation of how the elevators and escalators are distributed across our technicians. Each dot represents a single business, a single building that KONE is maintaining in their portfolio, and the color represents the technician that is taking care of that specific building. So you can see clear clusters of colors of technicians taking care of different areas of the city. The reasons why we are doing this are multiple. First of all, area ownership. So the technician feels the ownership and responsibility of a specific area of all the units, and all the maintenance, planned and unplanned, are typically the responsibility of one technician. Second, the customer visibility. So KONE customers appreciate to deal with one single person when it comes to maintenance and repairs for close relationship, trust, and for security on accessing the building. And third, the technical expertise. So the technician knows the elevator or escalator deeply, and whenever it comes the time of troubleshooting any issue, they are typically faster in solving the issue because they know the elevator or escalator in question at heart. So what we are trying to do with this project is to support the operations managers around the globe in managing at best the capacity available from their technician in their team, and to assign correctly the units to their technicians. So we have been working together with Solita on a new application for operations managers named KONE CAP, which stands for Capacity Utilization and Planning. There are two main functionalities of this application. The first is to review the historical capacity utilization of the technician in their team. And secondly, and even more importantly, the ability to plan the capacity needs based on the expected future workloads of the units. And in this way, being able to manage proactively the capacity needs.
Thanks. But what are the main features of CAP? So the first one that we're going to talk about is the equipment geocoding. In CAP, we have the possibility of setting the latitude and longitude of the equipments as well as their address. The quality of this data is very important in the application because it's used to estimate and forecast what is the travel that is required by the technician to drive between the different equipments. So the application has the possibility of setting more accurate latitude and longitude based on equipment address, or vice versa, depending on which data quality is better. The second feature is the workload forecasting. KUP provides the possibility to forecast the expected workload for each equipment for the year, broken down at a monthly level and also at an activity level. So if it's planned maintenance, unplanned maintenance, repairs, and so on. So it's not enough to know exactly or as accurate as possible how many hours are going to be required by each equipment during the year, but it's also important to have it broken down at activity level for better planning. And finally, route optimization allows to optimize the assignments of equipment to maintenance technicians based on the equipment location, the technician capacity, so how many hours will they have available every month and during the year, as well as their skills. Let's have a look at what CAP is from the inside. So here you can see a high-level solution architecture of CAP, as well as other KONE systems that are not part of CAP, but with which we interact as an application. The three main components are those highlighted with the pink background. In the middle, you will see the application itself, which is a microservice application implemented in AWS. That includes a front-end, a back-end, the application databases, the various security groups, as well as the login and permission services. On the top right, you will see the data pipelines that read the data from the ingestion layers, process it, and make it available for the application. And these pipelines are implemented in Databricks. The last components are the AI models. They are also implemented in Databricks, and they comprise the forecasting as well as the route optimization model. Finally, on the left, we can see the integration between CAP and SAP, which is KONE's operational data platform, which is necessary for pushing changes from the application itself into KONE production systems. Let's have a look at some focuses of CAP. The first one is about the forecasting models. We talked about how and what the forecasting model is there for, so to predict this monthly number of visits and hours for each equipment broken down by activity type. These forecasts need to be accurate. They need to be scalable by a million of equipments, as Alessandro said, and they need to be broken down by activity type. So how do we address these problems? We use historical maintenance records. So we have detailed data about every activity that maintenance technician performed on equipments, what it involved and how long time it took, as well as contract data. So how long has the equipment been in service by KONE, and if there's any contractual obligations that need to be performed on that equipment. We also use a top-down approach. So we generate forecasts at the planner group level and broken down by equipment. In this way, we maintain a good balance between the accuracy of the prediction and the scalability of the model. And finally, we use Google Maps travel times APIs to accurately estimate the travel distance and time that is required by the technician to drive between different equipments. The second focus is on the route optimization. We discussed the goal is to find the optimal assignments of units to technicians based on the location, expected workloads, capacity, and skills in order to maximize some business metrics. The business needs in this case are very quick turnaround of results, because the supervisors need to be able to review the results, understand them, perhaps adjust them, trying different combination of settings, and maybe run the optimizer again. So there needs to be very interactive process. There's also the need to incorporate the knowledge from the supervisors or the operations managers on top of the results of the optimizer. And finally, the ability to store these results in KUB until they are reviewed and they are ready to be pushed to SAP. We tackle this through the use of Databricks serverless compute, which allow to get optimal assignments delivered in a matter of minutes using very scalable compute. And we also give the possibility of supervisors to adjust the results of the optimizer by manually changing the assignments, perhaps because a technician is more of an expert in certain equipments, or as Alessandro said, the client requires a specific technician to take care of it, and so on. And finally, we have this possibility of keeping the data staged in the application DB until it's time to be pushed into production. Finally, we talk about the systems and data integration. So in CAP, we have 4 different data systems that interact between themselves. We have Databricks, which is KONE's enterprise data platform, and then we have SAP, which instead is used to store operational data. We also have the application database, and we have the local browser session where the CAP user works. And some of these systems don't really sync in real time. For example, the SAP to Databricks integration only happens once a day. So we define this data consistency mechanism that allows the data to be kept in sync between the 4 different data systems, so that there is no ambiguity on where the data comes from and what's going to happen when it's changed. Finally, soon we are going to release a functionality that will allow multiple users to work interactively and collaboratively on the same data in the CAP, so further enhancing this data consistency. I'll give the word back to Alessandro.
Thanks. So here you can see a sample screenshot of one of the views in CAP. So you'll see a stacked bar chart on the left side, where there is the solid color. The operations manager can visualize clearly what is the workload back reported by the technician in the last 12 months, clearly distributed by different colors. So the blue is representing the planned maintenance on the elevators, escalators, the yellow, the repairs, and such. And on the right side of the image, with a pale color, it is represented the expected workload, so what Roberto was mentioning as the workload forecast. And here, even in this case, it is divided by activity types, from the planned to the unplanned maintenance to the repair workload expected. And the red dashed line represents the capacity of the technician. So in one unique view, and this is a sample of the whole application, the operations manager can clearly visualize if the expected workload for this technician is about to overload the technician or underload the technician, and take decisions proactively in changing the assignments of elevators and escalator to the technician so that the workload in the coming months is balanced for the technician in the months and also between the technicians in the same team of the operations manager. To conclude, we would like to show some business takeaways that we have learned together with Solita since the beginning of the project. First of all, scalable technology needs local intelligence. We have understood very quickly that the models, both at the forecasting level and the optimization level, they need local intelligence to be rightly fine-tuned. The reason for this can be multiple. Roberto mentioned about customers that specifically wants a technician to maintain their elevators, or customers that are requiring some certain specification in the maintenance operations. And consequently, the model does not necessarily know all the truth, and the local intelligence is needed to fine-tune and to make sure that the results is then applicable on the field work. The second main point is about the cultural and behavioral change on the operations managers and the supervisors, which are the application users. So traditionally, the operations manager, but above all the supervisors, are field people. They are very close to their technician, very close to the customer, to the maintenance of the elevators. We are asking them in this AI transformation process to step up from that role and to be able to visualize the workloads proactively and understanding proactively if they need to take a decision in changing the assignments from one technician to another. Above all, in case that we're winning big contracts and then eventually the capacity of the team needs to be correctly adjusted. This means that a cultural and behavioral change in their role is necessary for them to be active and to be proficient in this role. The third point is to keep it simple as possible. Most of these users, operations managers and supervisors, are not expert neither in AI nor in optimization, and this is why we are asking them to interact with this model and to make changes and to make refinements to the model results. So this model needs to be kept simple so that we are also able to explain them why the model is generating those kind of results, and then proactively taking care of modifying the models, or making sure that the user understands the reasons of the model proposing a certain solution. In all of this, the interface needs to be as intuitive as possible, guiding the user naturally through the process, which in this case starts from geolocating the elevators and escalators on the map to visualizing the forecast until getting through the route optimization results. So with this, we thank you for your attention, and we are happy to answer any comments or questions in the chat.
Thank you.